Okay, now I'd like to do problem page 204, D. I'll do D3. Now, D3 is asking us, and again I have it on the right side here, we want to write the symbolization key and symbolize the argument. So here's our sentence. All my dreams are black and white. Old TV shows are in black and white. Therefore, some of my dreams are old TV shows. Um, so we have a few things going on. There's something about being a dream. There's something about being black and white. There's something about being an old TV show. And that's it. So we need three predicates to symbolize this argument. So let's look at the way they symbolize the ones above. So they do it this way. So we'll do the same. So we'll put, the function sort of formula. We'll put the colon. We'll put an underline, and with the x sort of referring back to that the variable, and then the completion of the sentence. So first we want to do dreams. So we have d of x, and we would say, well, that would mean that x is a dream, because we will need to be able to identify something that's a dream in our symbolization. Black and white is something else that we need. So I don't know. Let's use capital B for this. B of x. So that would be that x is black and white. Okay. We also have old TV shows. So let's maybe do O of x. X is an old TV show. So that is our symbolization key. We don't have any proper names in this problem, so we don't need to give names to anything like we would maybe in D4. Maybe I'll do D4 because I did assign D2 and D6, and that has a name in it, so I should do one with a name, but I'll do D4 after this one. So now we have to symbolize all these sentences. Now the first one is, all my dreams are in black and white. Now the word all is a very big hint that it should be a universal quantifier. So if you're a dream, then you're in black and white. Okay. Now it does say my dreams. We could update our predicate to say my dream. Because they do that sort of consistently among both. So, okay, that's fine. So to symbolize the argument, it would say the following. All my dreams are in black and white, So it would be for all x, dx implies bx. That's the first sentence. For all x, if it's my dream, then it's black and white. That would correspond to this sentence. This says old TV shows are in black and white. Now they didn't explicitly say the quantifier. They didn't say all TV shows are in black and white. But when you say something like that, it's usually understood to mean all. Okay, because it's kind of saying, TV shows in general are old TV shows in general are in black and white. So the second sentence, we would say for all x, if it's an old TV show, then it is in black and white. So for all x, OX implies BX. So then the third sentence, therefore, some of my dreams are old TV shows. So the word some is an existential quantifier. We're not as strong as all in that case. So we'll say there exists x. That's there is an x that's both one of my dreams and an old TV show. So dx and ox. Now I don't think that's a convincing argument. Okay, I don't think it's valid, But again, we're not interested in validity or whether it's true or not. We're just interested in symbolizing. Now, at the end of this, you have to think, do I really need to specify a domain at this point? I guess technically I should, but I'm more interested in you making what the predicates are and the symbolizations. The domains can come later. I mean, you could say the domain is the collection of my dreams, things that are black and white, and old TV shows. Even though old TV show is kind of a vague category, you could maybe look at the set of all TV shows, but that gets into problems that I don't really want to get into about, well, how do you define something to be old or not? You'd have to set some kind of cutoff and so on, and it's not really interesting or germane to the point here. Okay, the point was make the symbolization key by defining predicates and then symbolizing them, and if you do that, then I'm happy in this case. Now, I also said I would do D4. So here's D4. D4 is this argument. Neither Holmes nor Watson has been to Australia. So there's two names in this case, Holmes and Watson, and Australia, the country. So now it says a person could see a kangaroo only if they had been to Australia or to a zoo. Now, only if is a little tricky. They're essentially swapping the order of an if-then. So really it means if they had been to Australia or a zoo, then they could have seen a kangaroo. But I guess kind of it says only if. The word only is kind of strong there, right? Does that... only if. So I guess you kind of want to be exclusive, that if they have not been to either of those places, then they don't see the kangaroo. How would we do that? Well, let's think of our symbolization key, and then we'll worry about it. That's something that may require us to think a little bit. Then they say, although Watson has not seen a kangaroo, Holmes has. So those are going to be just sort of predicates with certain names in them, maybe with a negation on one of them, and then therefore Holmes has been to a zoo. So, okay. So I think we'll do the only if as an if-then. This way, I'll have to think about it. If I come up with a different thought later, I'll email it. Okay. So let's think about the predicates that we have. Now, Australia is a proper noun, but how is it used? It's always has been to Australia, had been to Australia, and that's the only time it's appearing. So, although Australia is a good candidate for a named constant, this section is technically, what is this, section 22? This is sentences with one quantifier, and I don't know, maybe they did do multiple predicates with multiple variables in this case, but the point is that it's only ever used with Australia. So we could build that into a predicate, or we could make a two-term predicate, that has a person and a place, and then use Australia as a place. You can use either, okay? It doesn't really make a difference. But because it's only has been to Australia and had been to Australia, I'm going to build it into the predicate. If there were two things in here, like one has been to Australia and the other one had been to Russia, then I might make a predicate for has been to, with the left side being the name and the right side being the name of the place they went to. But in this case, I'm just going to build it into the predicate. So I'm going to let here A of X mean X has been to Australia. Now, you have to be careful here. I guess maybe don't worry about it, but had and has are, they're functionally the same word, just in a different tense. This is it's like a present tense, and this is a past tense. We don't really make that distinction in the logic. So, past tense or whatever is not a big deal. In logic, sort of everything is in present tense. So we don't worry about that here. I'm sure there are logics out there that do past tense in some way or another, but first order logic is not one of them. So that's our first predicate. Could see a kangaroo is something that is appearing elsewhere as well. So let's say K, capital K of X, is X has seen a kangaroo. And if they had been to a zoo. I guess we have been to two different places here. So we could have done a two-term predicate here. Maybe I'll symbolize it both ways. Okay, so we'll say z of x to mean x has been to a zoo. Okay, that's one way to make a symbolization key. We also have to have our named constants. So we would have Holmes and Watson. So H is Holmes and W is Watson. And that's going to be the first symbolization key I use. Like I said, I'm going to do it also with a two-place predicate on the right side of those vertical lines. That way you can see it both ways. I, of course, will accept either for credit. So let's look at the first sentence here. Neither Holmes nor Watson has been to Australia. Nor is, again, one of these words like but that just means or, but it's in English, it's combined with neither in a strange way. So they're saying Holmes has not been to Australia, and Watson has not been to Australia. So actually it's serving as an and. My apologies. Neither nor means both didn't, right? So that's tricky. So both have not been to Australia. So you would say that not a H and not a W. That would correspond to Holmes has not been to Australia and Watson has not been to Australia. Okay. So that handles the first sentence. The second sentence says, a person could see a kangaroo only if they had been to Australia or to a zoo. So we're going to not worry about the word only here for now. And we're just going to say if they had been to Australia or if they had been to a zoo, then they could see a kangaroo. So we're going to say, now it just says a person here. So that's kind of an arbitrary person. So that is a case where we're talking about an existential, okay? Or no, a person. It's kind of an arbitrary. It's for all. My apologies. We're not saying there is a person that did it. We're just saying anyone that would see a kangaroo if they had been to Australia or to a zoo. So we're going to do it for all here. And we're going to do an if. And the if is going to say if they had been to Australia or if they had been to the zoo. Now, in our current symbolization key, that would be A of X or Z of X. So either of those. Now, we'll put parentheses there to indicate that that's the antecedent of the implication. Implies that they could have seen a kangaroo. Now, has not seen and could see, again, this word could is tricky. Could is a little weaker than actually seeing one. And so we're going to have to take a kind of, take it with a grain of salt here and say maybe a person sees a kangaroo only if they had been in Australia or the zoo. That's, again, one of these things that are tricky to symbolize in logic. So the word could, we're going to essentially ignore it here, and we're just going to say if they'd been to Australia or the zoo, then they saw a kangaroo. Again, that's strictly a stronger statement than what the thing says, but we don't really have a way around it. So we'll say k of x here. We could make another predicate for could have seen a kangaroo, but that seems to me to be messier than what we did. So they say, although Watson has not seen a kangaroo, Holmes has. So the third, let me keep these things separated here. The third thing says, Watson has not seen a kangaroo, so not kangaroo Watson, but Holmes has. So it's actually an and here. Holmes has seen a kangaroo. Both are the case. They say, therefore, Holmes has been to the zoo. So, therefore, Holmes has been to the zoo. So that would be Z of H. Now, we saw here that has been and has been was used twice. We could have a two-place predicate doing that. So let me show you how you would do that. Let's maybe use B, X, Y, and we would say X has been to Y. Now, if I do that, then I could keep K of X is X has seen a kangaroo, and to symbolize it now, I would need to make both of these also make them also names. Now, I can't use Z for the zoo, and again, that comes back to the fact that our system of first order logic is saying the letters A through I think S are reserved for named constants, and the letters T through Z are used for variables. So we won't use Z for zoo, but we'll pick some other letter. So we'll have A is going to be Australia. This is a problem, right? I used W for Watson. I could not have done that. That's a mistake. So how would I correct this? Do I have another color? Yes. So Watson. We can't use W for Watson, so maybe we use T. So then all these W's should really be a T. So interesting. Okay. Okay, now zoo, maybe we'll use little O for zoo. We'll use, again, H for Holmes. I really shouldn't be using equals here either. I should be using the colon. And we'll use T for Watson. Okay, so now with this symbolization key, I can again symbolize the argument. Neither Holmes nor Watson has been to Australia. So has been to is this predicate, B, and to say that Holmes has not been to Australia would be that B, H, A, and to say that Watson has not been to Australia, so I need a not in there and a not in there. Watson, so that's T in our symbolization key, has not been to Australia, that's A. So it is a little more complicated because we have a two-place predicate for has been to, but not impossible to do. The second sentence, a person could see a kangaroo only if they had been to Australia or zoo. So again, we're going to take with a grain of salt the word could and only if as the way we did before. So we'll say for all x, if you've been to Australia, so if x has been to Australia, that's how we would write this, or x has been to the zoo. I shouldn't use that second parenthesis. Then, oh yeah, I should. This one closes there. Yeah, that's correct. Because there's this bigger one sort of around everything. Then, X has seen a kangaroo. Like this. So that would be the second sentence in the way we've interpreted it. Then they say, therefore, Holmes has been to the zoo. Oh no, it says although Watson has not seen a kangaroo, Holmes has. So that sentence is more or less unchanged. Watson has not seen a kangaroo, and Holmes has seen a kangaroo. Finally, therefore Holmes has been to a zoo. You would again have Z of H for that. So that is D4. I'd like to do maybe, well, I think that's enough. So we'll stop there.